Okay. Oopsies. Okay. Um. Oops. Okay. Hi, my name is My-Hien. This is my Section 1 video presentation. I will be talking about quantum physics for babies. Quantum physics starts with the story of a ball, and this ball has energy and cannot have energy depending on what it is doing. It takes a deep dive into what is inside this ball, which is atoms. Atoms are inside this ball, and inside these atoms are protons and neutrons being circulated by electrons. And this is all displayed and discussed throughout this book in a way that is simple and engaging for young readers, even as small as babies. It also goes on further to discuss the electrons and where they're placed in their electron orbits, where they cannot be placed, and the energy required for these electrons to move or to fall. And it concludes with labeling this energy called quantum, hence the book Quantum Physics for Babies. As you can see here, this is the first page of the book where it says this is a ball and this ball has energy. The visuals in the books are very simple yet engaging, similar to what the book is all about. It has a white background, and this allows us to just focus on the image ahead of us, which is, in this case, the ball or the energy surrounding the ball in this one. And on this page, there are the atoms that we are taking a deeper look into. And on top of the simple display, we have colors that coincide with the drawings and the words. As you can see, neutrons is written in purple ink, and the neutrons themselves are the purple balls in this atom. Here we have protons written in red, and the proton itself is a red ball. Same for electrons written in green, and the electron itself is a green ball. So, what genre is this book? This genre is a children's book. It is also nonfiction, it is science, and it is a board book. It falls under all of these because it really is for young readers, although anyone of any age can benefit from reading this book. It is nonfiction because it does talk about factual information in science about what a ball is, what is the energy called inside of it, what are the atoms, their names, and what are their functions. It is science as it discusses quantum physics, and it is a board book because it is that boardy type book, small square like this. I didn't get to get a hard copy myself, so I cannot show you right now. And this is my favorite quote. It is at the very end of the book, and it says, "Now you are a quantum physicist." And this is the perfect message for anyone reading this because it shows that anyone is capable of being a quantum physicist, and it doesn't have to be as difficult as it might feel when you're introduced to it in a different way that isn't this book. And here's why you need it in your library. This book encourages critical thinking. It helps young minds think about the intangible things in the world that they might not be able to see, but that are definitely there. And although people may think it's too difficult for babies or young children, this idea that it's too difficult may stem from the general confusion many people might face when they're introduced to physics at an age such as when they're in high school or they're even in college. I know for myself, it was a really difficult concept for me to understand. Um, right in front of me. I understood it in theory, but this book really helps put it into a simple way to understand and not overthink. And I think it's important because it does make a difference in the history of teaching science by teaching it super young. We no longer have to worry about students being hit by this in high school and not understanding at all what it means, similar to how many of us might have felt. And it prepares them for success growing up. They become familiar with it at such a young age, the same way that they can become familiar with animals and colors and know their names. If they didn't know what a cow was, they wouldn't know what a cow was. Same thing with an electron. But if you are able to introduce them to those electrons, those neutrons, to energy, it's just something that's in their knowledge, and that really helps them succeed in the future and just become better people one day. And the activity I thought of was an electron dance party. Um, So electrons do circulate around the nucleus, which contains the neutrons and the protons. So you could have a student stand in the center, and they would be the nucleus, consisting of the neutrons and the protons, and they would put on their little beanie, and attached to that beanie would be the nucleus, which has the red protons and the purple neutrons. And they could stand there, they could bounce up and down, they could spin around, but as long as they're staying in their one spot, they would be the nucleus. And then you would have your electrons. They would be dancing all around the nucleus, and they would have their beanies with their electron on it. You could have a bigger electron. I would love to have like a much bigger electron, kind of to match the size of this culmination of a nucleus. And they would just be dancing around, spinning around, going all around the nucleus. And you could have music on, and it would just be a fun way for kids to remember what they learned about the electrons and physics itself. Because I'm imagining teaching this to TK, kindergarten, or first grade, and what little kid, most of them, don't love to just spin around to music. I think it would be amazing, and it would teach students to understand how electrons move around the nucleus in different paths while the neutrons and protons stay together in the center. Catch you on the next energy level. Thank you.